And increasing and decreasing functions. So a function f is increasing on an interval if any two x values in the interval where the first one is smaller than the second one, we have y value of the first one is smaller than the y value of the second one. The function is increasing when the tangent line has a positive slope. So increasing just means it's going up. So if you look at the graph they gave us over there on the left, do you see that it is increasing right here in this part? So where does it start increasing at? Well, it starts increasing right here. So it's going to increase from where x is 2 until, well, wherever x stops at, which is positive infinity. So it says the function increases on the interval, so it's going to be from 2 to infinity. Now, increasing, decreasing, and constant, guys, at the 2, it's actually not doing any of it. So we're going to always use a parenthesis when we're dealing with increasing, decreasing, and constant. And that's because at that 2, is it actually increasing, decreasing, or constant? It's not doing anything until right after that 2. All right, so then the next part there says a function f is decreasing on an interval if for any two x values in the interval where the first x value is smaller than the second x value, the first y value, though, will be bigger than the second y value. The function is decreasing when the tangent line has a negative slope. So just basically, guys, decreasing means it's going down. So is this graph going down anywhere? Now remember, though, you read the graph from left to right. So even though we have that arrow saying it's going up, as I come from the left to the right, I'm going this direction if I was drawing it. So I'm actually going down. So this is decreasing right here. So where does it start decreasing at? Well, somewhere way over here on the left. So we're going to say negative infinity. And it stops decreasing right there, which is at the negative 3. So my next sentence says the function is decreasing when the tangent line has a negative slope. This occurs in the interval from negative infinity to negative 3. Finally, a function f is constant on an interval if for any two x values we have their y values are equal. The function is constant on the interval here. Well, remember, constant just means it doesn't change. So where is it not going up or down? Well, that's between these 2 points here. So right here is going to be constant. And so where does it start being constant at? Well, let me erase my little parentheses here. So it starts to be constant right after the negative 3, and it ends right there at the 2. So there's the interval on which this one's going to be constant. It's going to be from negative 3 to positive 2. Now, when you're looking at increasing, decreasing, and constant, guys, your entire domain should be used. So if you look, we used from negative infinity to negative 3. We'd use from 2 to positive infinity, and we used from negative 3 to 2. So you should use the entire domain of your problem when you're dealing with increasing, decreasing, and constant, because it has to be one of those. All right, I'm going to go ahead and include the next part with this because we've already talked about it. Oops. All right, so our next part is going to be maxima and minima, and it says for any function f, if there exists on an interval from x1 to x2 that contains a c, so that for all x not equal to c in the interval, then f has a local maximum at c. It's just notation, guys. When f of c is greater than f of x, and f of c is called a relative maximum of f. So we've already talked about this. We've talked about a relative maximum, and they even gave us the other word. We called it a local, okay? And then vice versa, we could also have the local minimum. It's also called a relative minimum. And we've done this, so we know our maximums are our hilltops. And we know our minimums are our valleys. Remember, they're called relative or maximum. Relative or local because it may not be the maximum or the minimum of the entire graph, but it is for a small section of it. Alright, so then down here on example 3, it says at a local max, the graph changes from increasing to decreasing. On the graph at the right, shade the intervals of increase in green. So I know you may not have green, and if you don't, just pick a different color or something here so that, or, you know, pencil and pen. If you've got colors, that's great. If not, it's okay. You can just even write increasing or decreasing. But it told me to show where it's increasing in green. So that would be here, because increasing is going up. And that would be here. Alright. And then it says at a local minimum, the graph changes from decreasing to increasing. On the graph at the right, shade the intervals of decrease in yellow. And so this is just where it is decreasing, and that has got to be like the ugliest yellow I've ever seen. But it's alright. So there's where it is decreasing. And so we can see where the change, they didn't say it here, but this is what they're building at. The change from increase to decrease is a maximum, and the change from the decreasing to the increasing down here was our minimum. Alright, so I'm going to save the rest of this 2.3 for Wednesday and Thursday. Hope this gets you through part of the assignment. If it talks about the intermediate value theorem, or let's see what else is there still coming up here. Concavity, points of inflection. Yeah, those just wait. That's going to be our Wednesday, Thursday. Follow it up. Get it all completed kind of lesson day. Alright, so guys, I hope this helps. If you're running into trouble, please let me know. I can do what I can in video for now and then go over what we still need to go over at the next time I see you in class. Alright, so good luck and let me know how it's going.